Welcome to this lecture on basic medical statistics. Before we start, we need to understand the types of data. The data can be categorical data, what we usually get from cross-sectional studies or retrospective studies. They are usually expressed as a percentage of success or whatever. And we can do a chi-square test or Fisher's test to check the association between those success rates. We can also do an odds ratio or relative ratio if we feel that one particular factor is causing the other outcome. For example, smoking leading to lung cancer, then we can say that we have to do a relative risk. Then we have a continuous data. These are all a set of numbers where we have serum levels or flow rates. So we have to express them as a mean or standard deviation if they are normally distributed. By normal distribution, what I mean is they are distributed in a bell-shaped curve. Whereas if they are not normally distributed, that means the distribution is skewed, and we have to express them as a median and interquartile range and use non-parametric tests like Mann-Whitney test. What all statistics we can do ourselves? So the confidence interval, two-group comparison like chi-square and Fisher's. So these are the things we are going to see today. Risk ratio, odds ratio, students t-test, paired t-test, Mann-Whitney test. So all these things we will see today in this lecture. What we won't see is ROC curve, correlation, regression, survival analysis, multivariate analysis, forest plots, and funnel plots. We won't go into the details of all that because we do not have time for that. Now let us look at this retrospective study. So they looked at topical steroid therapy for phimosis. So they reported that 50 out of 61% patients had a success rate, which is 82%. So whenever you express this success rate in any retrospective study or cross-sectional study, you have to express this in terms of 95% confidence interval. So how do you obtain that 95% confidence interval? So I use this calculator, online calculator, which is available free. So I go to this graph pad and then enter the value there, 51 out of 50 out of 61. So and then compute confidence interval. So and then I find that it immediately gives me the 95% confidence interval. So that is a simple way of finding out the confidence interval for any data. Now let us go into another thing called 2 by 2 table. So 2 by 2 tables are basically to compare proportions. So here we can use a chi-square test or Fisher's exact test if that particular value is less than 5. So in this particular study, they've looked at the association of an abnormal meatal configuration and the need for further dilatation. So the basic risk factor or the exposure is abnormal meatus. So it looks abnormal. And the outcome is either the need for multiple postoperative dilatations or no dilatations. So we have here 3 out of 24, that is 12%, and 6 out of 90, 6%. So we are comparing 2 percentages here. So this is 3 and 21, and this is 6 and 84. So that's what we have to enter, not the actual total. So what we go is we again go into the calculator, and then we go to Fisher's chi-square kind of the column, and then we enter the values. So 3 and 21, and we enter 6 and 84. So it automatically calculates itself when we apply the Fisher's test, then it computes the total. So that is what the 2 by 2 table, and then it has come out with the p-value of 0.39. That means it is not statistically significant. Now we have 2 types of studies when we do the research. A cohort study where there are 2 groups, exposed and not exposed. For example, smokers and non-smokers. So we follow them up and then see whether lung cancer happens or not. So that is a risk. So we look at the risk between them and we use a relative risk. We sometimes don't have the time for all that. So we look at the patients who have already developed the cancer and then who are not cancer patients. And we go back and ask for the history whether they have been smoking. So the odds of a cancer patient being a smoker versus the odds of a control patient being a non-smoker, that is where an odds ratio comes. So let us see that again with some examples. But before we go into further, we need to understand this. When you make this 2 by 2 table, you have to remember that the disease and no disease appear like this, and exposed and not exposed appear like this. So only then you will get the A, B, and C, D correct. Otherwise, you will not get it. So the outcome is always on the top. So in this page, in this study, they have looked at the bleeding and no bleeding in patients with the BXO and no BXO. So here the BXO is the exposure and bleeding is the outcome. So they are comparing 2% versus 0.3%. And then they are looking at the relative risk or risk ratio. So how do we work it out? So we go to this particular calculator called MedCalc. So we enter the data here, A, B, and C, and D, whatever we saw in the columns and rows, and then we do the test. So when we do that, it will immediately give us the relative risk. So we do not have to go into the details of the formula to look at all this. We know the formula already from the theory, but we need to work it out. So instead of using a calculator, when we go to these online tools, we can easily do all that. Now let us look at this study. In this study, they are looking at the odds ratio. So they have looked at the patients with BXO and patients without BXO, and then they went back and found out whether who was obese. So the obesity was the risk or whatever they were looking at, the causative factor. And they went back and found out how many out of BXO patients had obesity. And so that is looking at 2%. The odds of obesity in BXO 42%, whereas the odds of obesity in non-BXO patient is 12%. So that odds ratio, how do we look at? Again, I go to this calculator and then enter all the data. Here, the A and B have come here, and C and D have come here. So you just have to remember where this, where to put the disease is always on the top on the columns, and the exposure is always on the left side on the rows. And that's what the odds ratio is. So we know that that's the odds ratio, and that is a significant higher odds of BXO patients being obese. Now, how to look at mean? It's very simple. To determine mean, all you need is an Excel tool where you enter and then ask for the average. It immediately gives you the average. For standard deviation, again, you go to the same function. Instead of more, you choose more functions and select the standard deviation, and then it gives you the standard deviation. So this is one way of looking at it. So here is a study where they looked at ballooning of the foreskin and physiological phimosis. Is there any objective evidence of obstructive voiding? So what has been done is they've done a urinary flow rate, Qmax, and so see whether the ballooning actually means there is a drop in Qmax. So this is what the findings are. In boys with ballooning, the Qmax was 15.3. In boys without ballooning, the thing was 15.4. And what is given in the bracket is the standard deviation. This is the number of patients. So this was not statistically different. So how do we prove that? So we have to go to this quick calculators again. So basically here we go to the continuous data. This is not a categorical data, this is a continuous data. So we go and then find out t-test to compare two means. And then here, instead of entering the data, we can enter the mean, standard deviation, and number. So here we are going to enter all the details. And when we enter the details and then say calculate now. So here, one of the way of doing it is, we can do it multiple ways. You can enter standard error of mean also, but we enter the calculator. This is an unpaired t-test. So I'll tell you about the paired t-test also later. So this is an unpaired t-test. The two-time p-value is 0.94. This is not statistically significant. Now, when we look at a paired t-test, so these are the patients who with a BXO, and they had a tacrolimus. So this is the uro flow before tacrolimus, and this is the Qmax after tacrolimus. So here, the same patient is being compared. So this is a paired t-test of an outcome of a medication before and after. This Qmax is being compared. So the raw data is here. So I'm going to show the SPSS. So I've just copied and pasted the SPSS data here. So we go to this analyze paired t-test and enter all the variables into wherever we have to put it. And then we just have to say that if there are some options, we can choose some options. Otherwise, we can say okay. And then it will immediately give us the the paediatric test outcome. So here, the outcome is significantly different. So we will have the significance level at the bottom, right? So here the man-Whitney test. So this is the test to compare non-parametric. So here, the number of dilatations needed in a patients with the BXO and without BXO. So each one is coded as 1 and 2, and this is the number of dilatations needed. So if you look at this, a simple way of looking at it, this is a skewed data. So we need to do a non-parametric test, man-Whitney test. So we copy the data here and then go to non-parametric test, and they are independent samples. So we go for independent sample, man-Whitney test, and then test variable, grouping variables. So each one is divided into group 1 and 2 here. So this group 1 is BXO and then non-BXO. We put it, we get the man-Whitney, and then we also get the significance at the bottom end. So here it is significantly different. So that is about man-Whitney test. Now, sample size is one of the important things which we need to know. Why we need to know? Because when we compare two groups, only when the sample size is adequate, you can show that there is a difference. For example, when you are comparing open versus lap reimplantation, so the difference in success rate is like 95 and 80%. That's a 15% difference rate. So the sample size probably is like 75 in each group. So total 150 patients you need to show that there is some sample size. But when you compare open and lap pyeloplasty, it is not 95 and 80, but it's actually 95 and 90. So only 5% difference. That means when you enter the data, it will automatically ask you to create more samples. So this is important. So class sample size calculators are also available online. So all calculators are available online. You can read the basics and statistics in your books. But when you come to practically doing it, you need to use all these various softwares. So thank you for listening to this talk.